after the program has ended. And eventually I became Kyverno maintainer.
Great. And Amar?
Hello, everyone. I'm Amar. My journey is actually very, very similar to that of Mariam. I started out my journey as an LFX mentee and continued contributing to Kyverno and stayed active in the community until I have became a Kyverno reviewer. And I'm happy to be sharing some of the new stuff that we've been working on in today's live stream.
That's great. So today we are going to dive deep into the new policy types introduced in Kyverno 1.15. But before that, before getting into the details and these new policy types, I would like first to take a moment to explain why Kyverno introduced new policy types in the first place. So I think I can now start sharing my screen, if that's okay. Okay. Okay, let's get started then. So what's Kyverno? Kyverno is a policy engine for Kubernetes, and it actually can be applied to JSON payloads. But in the context of this session, I would like first to focus on the Kubernetes resources. So to simply put, Kyverno is a policy engine for Kubernetes, which means that when you create a new resource, Kyverno looks for all the Kyverno policies that match this resource and it apply it. So to take an example, for example, like we have a cluster policy that makes use of the validate rule, and here the purpose is to validate resources. So for example, you might have a use case where you need to each pod must have a specific label. So you write a Kyverno policy that looks like this. It's of type cluster policy and it match pods. And then under the pattern field, you specify your validation logic, which in this case will be to verify that each pod has the team label. So what's happening internally is that when the user creates a new pod, this API request goes to the API server, and then the API server will forward this request to Kyverno, and then it is the responsibility of Kyverno to fetch all cluster policies that match the incoming resource, which is pod in our case, and then Kyverno will apply the policy to the pod, and it will simply return the responses back to the API server. And this means that if the pod violates the policy, like for example here, if the new pod doesn't have the team label, so Kyverno will reject the resource because it violates the policy, right? Otherwise, it will be allowed. So this is the validation rule. So you use it to verify resources have specific fields or has specific settings to follow the security best practices. And you might wonder if you want to mutate the incoming resources, what can we do? So for that purpose, we have the mutate rule. Again, you write a cluster policy and it match pods. Depending on your use case, you can match on any Kubernetes resource, of course. But in this example, it match pods. And then it makes use of the mutate rules. And as you see here, we say that if the team label doesn't exist in the pod, then we will add it. So Kyverno automatically adds label to the incoming resources. And actually, it can mutate anything, right? Like you can add a new container, for example, or you can add annotations. You can add, anything you want using the mutate rules. And finally, we have the generate rules. And as you see here, you can use the generate rules to automatically generate resources depending on other resources. Like for example, you might have a use case where you want to generate network policies for each namespace, right? So you can write again a cluster policy that match namespaces, and then generate either a network policy or a secret or whatever you want. We also have another kind of rule, which is verify image rules. And it makes sure that the images used in pods deployments and whatever resource that makes use of images in general, it is signed and verified. So as you see here, we have validate, mutate, generate rules, and these rules have been the core of Kyverno, and actually they are what made Kyverno powerful and flexible. And as Kyverno evolves and new features were introduced, we started to face some challenges. So to explain one of the challenges that we have faced so far, let's take a quick look at the validate rules. So for the validate rule, actually, if you have a problem and you want to validate a resource, you can write your validation logic in multiple ways. So first of all, you can write your validation logic under the pattern, as we have seen in an earlier example. Here, for example, we match on namespace, and we are making sure that this namespace have this label, right? This is one way to do it. Another way to do resource validation is to write a set of conditions under the deny. So here, for example, we have conditions, and we have this condition and the second condition, and whenever if one of the conditions are met, then this means that the incoming resource violates the policy. So you can write your validation logic in terms of conditions, and if one of them met or if all of them met, then we block the resource. Another way to do it, if you want to validate, for example, an image name or a container name, so you have to specify the for each to loop through the containers, and then you write your validation logic under the for each. This is one way to do it. And we also have the pod security sub-rule. As you see here, the pod security sub-rule is mainly for applying pod security standards to pods. So here you can specify the level and the version. As you might know, the pod security standards have 3 different profiles: the baseline, restricted, and the other profile. So what we are doing here is just that we specify the level and the version, and internally Kyverno will make sure that the incoming pod actually doesn't violate any of the pod security standards. And finally, we have the validate.cell subrule. Here you write your validation logic in cell expressions. So as you see, we have lots of things you can do just to write your validation logic. So if you have one problem, you can choose between using the cell expressions, for example, or you can use the pattern logic or the deny conditions and many more, right? So, as Kyverno evolves, we realized that having one policy type that provides everything is not helping at all. We need a more focused and consistent way to write policies, because at Kyverno we have always believed that to write policies, it should be simple to write and easy to understand, right? So we were trying to figure out the next steps for us, how to make policies more easier and more understandable and user-friendly, of course. So at the same time, cell expressions was gaining momentum in the Kubernetes ecosystem. Because currently it's been used in lots of things in Kubernetes, like CRD validations. It's used in validating and mission policies. It's even used in the new mutating and mission policies, and so on. So Cell is becoming more powerful and flexible and easy to understand. So we decided to lean into this shift, and we do 3 things. First, we simplified the policies. which means that instead of having one cluster policy that has like lots of features and does everything, we for every for every rule type, we introduced a new policy type. So instead of using validate rule, now we have a new policy called validating policy. The same for mutation. Instead of using mutate rule, we now have a new policy type corresponding to this mutate rule. So we are trying to simplify the policies. So at the end, we will have, each policy will have its own purpose and goal. And the second thing is that we need to unify the policies. So all of them, he makes use of cell expressions. And this is the direction that Kubernetes has already taken. So we are following the Kubernetes ecosystem in this part. And finally, we want these policies to be more user-friendly. That's why these new policies makes use of cell expressions. Like there is no way to write your validation logic in other approach. Like if you have a problem, there is only one solution to fix it. Unlike the validate rules, you have multiple options and you can choose of them, but sometimes it's very hard and it's challenging to know which approach is better for this specific use case, for example. With that said, so in Kyverno 1.14, we actually started introducing these new policy types. We started with the validating policy and the image validating policy. They were already introduced in 1.14, and we had a live stream explaining them in details and the new cell functionalities that Kyverno provide for both of them. And today we are focusing on the rest of the policy types that we introduced for Kyverno 1.15, which is the mutating policy, generating policy, and the deleting policy. With that said, I think we can start by explaining generating policies if there are no questions so
We do
far.
have a couple of questions, Mariam. The first one is around original cluster policy. So is the original cluster policy now considered deprecated?
Yep, there would be like a deprecation plan for the cluster policies, but we haven't decided on it yet.
Okay, great.
Yeah, any other question?
We have a couple more, but it's more of a global question around Kyverno, so we can ask that toward the end.
Okay, that's great. Okay, so let's start with explaining more more the generating policies. So first of all, it is simple. It is the same as the standard generate rules. It provides the same functionalities as of the generate rules, but with like instead of this generating policy makes use of cell expressions. This is the only difference. So here we specify the kind as of generating policy, and then we have the match constraints. And in the match constraints, we specify, the trigger resource, like which resource that when it is applied, this policy will be triggered, right? In that case, we have the namespaces. And finally, the most important part here is the generate field. So inside the generate fields, you can specify a list of cell expressions. So for generating a resource, we had to introduce a new functionality in cell so that we can so that we can generate a resource. So here we have the generator library, and inside the generator library, we have a function called apply. And basically, it takes two parameters. The first parameter is the namespace, and the second parameter is a list of resources you want to generate. So simply, when you say, let me take, sorry. Yeah. So, for example, if we used it like in this example, here we have the generator.apply. And as I mentioned, it takes two parameters. First is the namespace. And as you see here, I am using the variable section to set some variables beforehand, like before using the cell expression itself. So here I am extracting the namespace name and store it in this variable. And as you see, I am using it in the apply functionality. And the other variable is the downstream. And as you see, it takes a list of, this variable is a list of resources, because the apply functionality takes a list of resources. So we do it that way. And yeah, in the downstream, you just specify the thing that you want to generate. For example, here we want to generate a config map. So yeah, we just provide the manifest of the config map that we want to generate in the variables section, and then we use it in the expression. This is one way to do it. Like if you don't have the config map already exist in the cluster and you want to provide its manifest in the policy definition itself, so you probably will define like this variable in the manifest itself. The other way is that you want to, like, if you have this config map in the cluster, so you want to fetch it from the cluster and then apply it in a new namespace, for example. So here, this approach is called cloning, because it is like copying one resource from one namespace and generate it in another namespace. So for this example, we have a generating policy with match constraints set to namespaces. And here, instead of providing the manifest in the policy definition itself, we are fetching this resource from the cluster. So here we say that we have this secret in the default namespace. We want to fetch it first, and we do so by using the resource.get. And if we go to the cell libraries provided by Kyverno, actually there are like lots of libraries Kyverno provides to extend the functionalities. So here, for example, we have the resource library, we have the resource.get and the resource.list. So if we use resource.get, this means it will fetch a specific resource by setting, the type of the resource we want to fetch, the namespace, and the name of the resource. And then you can use it whatever you like. You can use it in the validating policy, in the deleting policy, and whatever, right? And also we have the resource.list if you want to just list all the resources. And we will see example in the generating policy that makes use of this functionality. And it is the same. You specify the type of the resource you want to list, and you specify the namespaces. If you provide an empty namespace here, so it will list all the deployments from all namespaces. So to clone an existing resource into our new namespace, we just do as that, like we specify the type of the resource we want to clone, its name and what's its namespace, and then this happens in the variables section, and then we just use this variable in our generator.apply. And if we looked at cloning multiple resources, you might have a use case where you want to copy, instead of one resource, no, I want to copy like list of resources. So here we use the resource.list to list all secrets from the default namespace. And again, you use the sources in the apply in the cell expression. So here we are simply saying that all the secrets that you got from the cluster, we want to apply it, or we want to generate it in this new namespace. And yeah, I have a little demo for that. So Yeah, for example, here, it is the same example we have just shown. So we have a generating policy that match on namespaces, and then we have the source where we list secrets in the default namespaces, and whatever's, all these secrets, we want to just replicate it or copy it into this new namespace. And we have here,
Sorry, Miriam. You're
Yeah.
still sharing your docs screen.
Oops. Okay.
That's okay.
Yeah, let me share my screen.
While you share your other screen, we might work in a couple of questions
Okay.
from folks. But go ahead and there we go, and we'll get that added. We do have a couple of questions here, and so you might answer some of them in your demo, but just to call them out, we've got one that's asking, will the mutating policy be namespace only, or will there also be a cluster-wide mutating policy?
Yeah, so currently all the new policy types are cluster scope resources, but there is a plan to provide the namespaced version of them.
Great. I'm sure there are quite a few people who will be happy to hear that. We've got a couple more. Here's one from Let's Catch Up. That's a fantastic screen name, by the way. How do you define the config map in the generator expression without defining it in the variable? Is this a difficult thing to do, Miriam?
It's not a difficult thing to do. You can do it actually here, but I prefer to be like, it's always easy to understand if it is in a variable, because if it is inside the expression, I feel like it will be hard to spot or understand. But yeah, that's okay.
Okay. Let's catch up. I hope that answers your question. If not, or if you have other questions, you can always join us in our Slack channels for further assistance. And then just a follow up to that is, what are the advantages that this gives to define the generator expression in the variable?
So if we compare it with the standard generate rules, yeah, for example here, it's like a different way. So in the generate rule, you must specify the API version, kind, name, namespace, and the clone section, etc. But in the generating policy, you just use cell expressions. And as I mentioned earlier, the purpose of defining new policy types is to just unify using cell expressions across all of them, because in cluster policies, you have different rules in one cluster policy, like in one policy type, and each rule has its way to be configured, right? But in generating policies, validating policies, and the rest of the policies, you just make use of the cell expressions, and the library actually is used across all of them. So there is no a specific way to do something. It's just a general thing, and it can be used across all policies, depending on your use case, of course.
Okay, that's a very complete answer. Thank you so much. We'll stop there with questions for now. Go ahead and share your demo screen, and we'll keep going.
Yeah, that's great. So first of all, we have this policy that we have seen earlier. It just lists all the secrets from the default namespace, and then we use this cell expression to apply them in the new namespace. So first of all, I will create the secrets, because they have to be exist first, right? Okay, and then we will apply the policy. Okay, and now we have the existing secrets, and we have the policy. We can go ahead and create a trigger namespace. So because this policy match on namespaces, it will be triggered whenever a new namespace created. So we will create one now. Okay. So now we expect that these secrets from the default namespaces are generated, or are copied into the new namespace. So if we set if we run the command to get the secrets from this new namespace, we should see 3 secrets, right? And yeah, another little thing is that you can, enable the synchronization, which means that if you delete the source secret, like if you delete the secret number 1 in the default namespace, it should be deleted in the new namespace. And if you update it, then it should be updated in the new namespace, etc. Also, I would like to show the policy report generated. So here we have, here we have a cluster policy report generated for the test namespace. And if we look inside it very quickly, you will see that a cluster policy report generated for the test NS namespace, the namespace that we have just created. And it shows the results, which is applying this policy on this namespace resulted in generating these resources, like, these 3 secrets. And I would say that's it for my side. If you if you have any questions or anything you want, you can just ask on Kyverno Slack. And by the way, all the functionalities provided by the generate rule is supported in the generating policy. So you can use, for example, we have the generate existing functionalities. We have the support of the Kyverno CLI for the generating policies, and all the rest of the features are supported for the generating policy. And I think Ammar can start showing and explaining the mutating and the Kyverno policy and the deleting policies.
Thank you for the exquisite demo, Mariam, and the great introduction. And I will be showing to you guys right now the other types of policies which are mutating and deleting. So I'm going to start sharing my screen and let's get right on with it. So first of all, the mutating policy is the policy that corresponds to the old Kyverno policy that we had with mutating rules. It's now has been now consolidated into its own new policy type. And we can take a look at a simple one to see how it might look like. So, a second. I hope you can see it right here. So you can see that you're selecting the resources using match constraints, and you're specifying a resource group, and then the mutation in the mutations you specify the type of change or mutation that you want to incur to these resources. So you may have noticed that it is very similar to the Kubernetes mutating admission policies. And I would say that you are right in assuming this, but the features that Kyverno offers on top of mutating admission policies, such as reporting, you get generated reporting, and you can specify policy exceptions, and you can also package and ship your policies in many ways. You can deploy the custom resource using Helm, and you can also use the Kyverno CLI to get more out of your policies and be able to test them in many ways, which we will also be seeing. Similar to the generating policies, you can specify expressions which do tighten down or control further which resources will be controlled when, get the mutation applied on them once it matches the policy. I want to take a second to explain a point, which is I know that it can be a little bit intimidating to learn a new syntax, and it might not be very clear as to why both Kubernetes and Kyverno are moving on to in the direction of cell. But I would like to say that the performance gains that you have by having it directly supported in the the Kubernetes API server is amazing. And also you having to debug only one type of syntax and one type of policies rather than the many types that were existed before, such as James path and JSON 6902 and the other types of mutations that you could have specified. Now it is just one type of syntax and one type of language that is strong and expressive enough to cover most of your needs, or like actually all of your needs for your policy as code.
I think we'll take
So-
just a moment because this is fantastic that you're addressing learning a different syntax. We do have somebody who just asked if there is a place where they can find a good video about Cell, and also people who are already looking at, is there a guide or tool for migrating cluster policies to a new policy type? And I'm sure both of you have done quite a bit of work to learn Cell, and I know that there's a playground, right, that we're using to help people migrate. So can you speak a little bit to that before we move on?
Yeah, first of all, I would like to say that even that before starting to work with Kyverno and being involved in it, I wasn't knowledgeable of Cell at all. And by the time I started doing this, Cell was already gaining some traction. So it's not like I was early to the game. No, I came in actually a little bit late, and I found it very easy to learn through the Cell playground, which Courtney has mentioned. And we will also try to compile a bunch of useful resources that we can link to you guys and share with you later to level up your game with Cell expressions. But I can assure you that the learning curve is not steep at all, and you will be writing very effective and very powerful policies in no time.
Great.
Yeah.
Thank you.
Yeah, I would like also to add a small thing. So currently we have the policies library where we have like lots of cluster policies for different use cases. And now we are working on writing the corresponding policies for these use cases. So you will definitely, see like lots of validating policies and etc. for in the policies library.
Yeah, also, as we are migrating and as you, members of our community, are learning Cell, we would love it if you would actually come and help us move some of our policies, which are in the policy library, over to Cell. It would be a great way to test your knowledge, contribute to the community, and for us to get to meet you and interact with you, which is also always something that we love very much.
Absolutely, and I'm sure I will look for it while you continue with your demo presentation for the link to the Kyverno playground, Cell playground, because we have a lot of our users who are benefiting from this exponentially for both learning Cell as well as transferring their policies. So I will share that link in the chat in just a moment. Go ahead and continue, Amar. This is great.
Thank you, Courtney. So moving on, for specifying the mutation in the mutating policy, you have two ways. You have JSON patch and you have apply configuration. So you see here apply configuration. Let's see what JSON patch may look like. It looks as you are seeing here on the screen. You might be wondering, that or the other. The answer to this question is JSON patch is better when you want to modify, like, let's give, for example, you are replacing the list of containers in a deployment. You're going to specify a list, but Kyverno or the API server or whatever is going to apply your patch doesn't know exactly what to do with what you've given it, whether to replace the entire list or to add an entry in the list with the new item that you have in your mutation. This is an example where JSON patch is going to be better because JSON patch directly specifies where in the resource should the patch take place. And if, for cases apart from this, you can use apply configuration, which is essentially a cell expression to specify how it's going to be included, or how the resource is going to be modified. So there are some additional fields in the mutating policy, which we're going to open the documentation to see right now. 1 second. Yeah, so there are ways that you can generate a mutating admission policy from the mutating policy. You would specify it in the way that you see here. In AutoGen, you would say mutating admission policy enabled is true. And the benefit you would get from this is that you will have your mutating admission policies generated, which will be executed at the API server level, not in the level of Kyverno. So by doing this, you would have essentially saved yourself some time and some resources, because there is no admission workflow happening here. You're just creating the resource, and the API server is changing it, rather than going to Kyverno and say, hey, can you please change this resource for me? And then Kyverno says, here you go. You're skipping this step by directly generating the mutating admission policy from the mutating policy. And you can specify different types of controllers and different types of resources for you to be getting mutating admission policies for these as well. Anyway, back to the slideshow. Regarding evaluation, you can also control when, and in what cases does your policy evaluate. You can specify that it can have mutate existing, and you can say that it only applies when you create a resource or during admission. And the way that you would specify this is in the evaluation field. You would say mutate existing is enabled, yes or no, and apply the resource or the policy at admission, enabled, yes or no, true or false. So you can really control and play with the behavior of how your policies get executed and take place. Also, the killer feature that you get out of mutating admission policies more than, from mutating policies more than Kubernetes maps, I'm going to refer to them as maps now to avoid the confusion, which is the support of the CLI. And once you think what you can do with this, you can essentially build a pipeline in your organization to check what will the policy do for your resources, what changes will take place in your cluster from the policy that you are about to deploy. And we're going to see how this works right here. If we look into the test directory, we can see here that we're going to be running a Kyverno test where we're going to have a policy, a resource, and a patched resource. So let's see what the policy looks like. And we see here that it is a policy that adds a label to the config map of LFX mentorship is Kyverno. If there's already an LFX mentorship label on the policy. So let's see the resource as well. You can see here that it is a config map, a very simple and a normal config map, and we can test it, check in advance what is it going to be by checking the patched resource. And we can see here that the patched resource is the exact same config map, but it's going to have the LFX mentorship added on it. So let's test this out. And we can see here that the test has indeed succeeded, and the applying the policy to the config map that we gave it resulted in the and config map. So you can do this for any number of arbitrary resources, and you can even link it to an actual live cluster and check what will happen to the live cluster when you are about to apply the policy by using the apply command. So all in all, we can see that there are many amazing features that you're going to be getting out of the mutating policies. You're not going to be having to enable specific API server flags to get mutations or get mutation capabilities, which is what you will have to do with the mutating admission policies or the Kubernetes native ones. You will not be able to test in advance what your policy will do to your cluster. There will be no support for mutate existing, and you will be pretty much shooting an arrow in the dark with any new policy that you introduce. But with Kyverno, you have policy reports generated, and you can also use the policy reporter to send those reports coming from the policies to any data system, so you can think of your entire sort of ecosystem around your compliance. You can have, for example, reports that generate reports generated that you can send to many integrations that you can like notify your ops teams that, hey, there's a violation, or hey, some mutation happened. So there's so many many scenarios that you can build and configure using the tools given to you. So let's move on. We can see, we're going to be seeing right now a few functional examples of how the mutating policy comes into play in the Kyverno playground, which is also an amazing feature that I invite you guys to try, and we will see how it works in just a second. So let's start with a very simple example of a mutating policy right here that matches deployments and just adds a foobar label to the deployment. And we're going to be creating this deployment right here. This is the deployment, dev deployment, and pretty ordinary deployment. If we run this, we see that the policy has indeed matched the resource. And if we open the details and see what happened, we're going to see that the label foobar has been added to the deployment. For the next example, we're going to see another one with a JSON patch, also matches deployments and adds a managed label is true. So if we run this, we will get the same, we will get our mutated deployment. And then for another test that I would like to show you guys, or like another demo, which is the mutate existing feature. So if we get the mutating policies that we have here, we see that we have a policy. Let's see its spec. I don't know where it is. Okay, let's just view it as it is. And we can see that it is a policy that will trigger on namespaces, and it's going to apply a foobar label to config maps. Config maps to config maps that exist in namespaces which have this test-enabled label. So if we get our namespaces, we can see here that this is the namespace that we have created for our test. And if we get the config maps inside of it, we can see that we have a single config map. So we will create one in just a second. If we apply this config map, which, as you can see, is a config map that has no foobar label. And if we now go ahead and edit the namespace, and just add to it any change. Basically, we can just say existing no or existing Kyverno, anything. Great. So let's get our config map once more. And we can see that it has indeed received the foobar label. So this is about the mutating policies. Inside of a single, you can specify an array of mutation, and the array of mutation will be applied in the order that it appears. So the first entry in the mutations, in the second, in the third, and so on and so forth. But there is no ordering guaranteed across multiple policies. So if you have multiple policies in your cluster, they will be applied in an arbitrary order. You cannot control such a thing. So a tip for you, policy developers, make sure if you have mutations that depend on one another, that you specify them in one policy. And for the last thing that we would like to mention regarding mutating policies, which is the reinvocation policy. The reinvocation policy will control how and like what will happen if like when do you need to reevaluate the policy again. So if you specify to never, then it's going to just mutate the resource once per binding. And if needed, if it's going to mutate it whenever something modifies the object once again. So that was it for mutating policy. I hope that you liked it, and we can move on directly to deleting policies, or if maybe we can take a couple of questions.
I don't see any questions right now about mutating policy. That means you did a fantastic job explaining. But we can take a moment to pause. We do have one question around just general cell, which I think is it's a great question. They're wondering where we can see performance gains, where those can be expected in moving to cell-oriented policies. Do we have any thoughts on this?
So currently,
well, we can.
yeah, go ahead.
Sure, go on, Mariam.
Yeah.
I was going to explain that.
Amar first, in alphabetical order. They're both really excited to answer this question.
Yeah. So we have a few benchmarks we have tested for like when you evaluate the policies using cell, how long does it take given a number of resources in your cluster? How much is the latency and things like this? And you can view those numbers, and you can see for your policies and for your resource, what is the expected performance gain, or what is the expected performance that you will get out of cell policies when you apply them to the cluster. And Mariam, of course, if you have a more nuanced answer, I would love to hear your take.
No, I was about to say the exact same thing. So we tested both validating policies and image validating policies and compare it with the current validate and image verify rules. And we are in the process of doing the same for the rest of the policies to see like what's the performance gain that the new policy types comes with.
Great. Thank you for that. And then we have a couple other questions that are rolling in here, which is great. So we'll pause and answer them. What happens when two policies have reinvocation policy enabled?
Well, as mentioned, there is no ordering guaranteed, so you will get the both policies to modify the resource, and you cannot tell which outcome or what you will get out of both, which which will be the final change. If both of them specify or change the same field, you will get a random choice between the two policies.
Okay. Good to know. I think for now we're good with questions. Let's continue with our deleting policy, because this is also a fantastic demo.
Thank you very much. So moving on to deleting policies, as the name suggests, they are to delete resources from your cluster on a schedule. And they are fairly simple in their structure and in how they are built. So let's view the deleting policy that we have here. We can see that it is a very simple policy where you just give it the expression that you want to match on. And of course, you can use the other cell features that exist in the other policies, like variables and things like this, to up the strength and power of your expression. And you then specify a cron schedule that will trigger the deletion sort of cycle. And we can see this happening here through by applying, for example, this pod. So let's see the pod that we have here. It's a simple pod that is called example, same as what the policy is targeting. So if we apply this pod, it's going to be created, and within a minute, it will delete this pod, as we will be seeing. While it does this, I want to give some examples to what you can do with the enhanced or the more capable cell library that we have in Kyverno. You can not only get resources as Mariam has displayed, but you can also make requests to arbitrary HTTP endpoints. You can fetch objects from a global context entry resource that Kyverno uses, which will greatly enhance your performance for a given resource. And I would suggest you guys look into global context entry. Among many things that you can do with the enhanced cell library, which we will also be linking to people and sharing with people so that they can see the capabilities. And right now, if we get the pods, we see that there are no pods, even after we have created our pod here. In the default namespace, it was deleted because the deleting policy has removed it. So moving on from this example, I want to show some more advanced things that you can do with deleting policies. You can, for example, first of all, we have an example here that, one second, let me open it. Yeah, we have an example here of fetching a cluster resource using the resource library and validating that it will be using data from it in the expression. So here we're going to be deleting the resource if the label hello matches a value in a config map. So if we run this, we get that the resource didn't match. And the reason why it didn't match is because here hello equals test. But if we look at the cluster resources, we see that hello equals world. So if we specify hello to be equal test, and then run it again, we see that it passes successfully. So the sky is the limit and your imagination is the limit with what you can build with this. Another very useful example is you deleting deployments that don't have resources and limits. So we here have a cell expression that will filter out for deployments that don't have them. And here we have a deployment that doesn't have them. So if we start, we see that it matches the policy this means that it will indeed delete it when the cron schedule takes place. And if we bring back the resources and start, we can see that it's going to fail, meaning that it's not going to delete the resource. So yeah, and for this example, we have matching for pods called example, but on a much more complex or a bit more nuanced level, by specifying that the namespace should have the label environment equals to production or staging. So here we have a pod in the staging namespace 1 and a pod in the production namespace 1. And if we start the execution, we can see that both pods have matched. And the reason for this is if we see the cluster resources, we can see that the namespaces indeed have the environment label of staging and production. So I guess with this out of the way, the only thing that needs to be said extra on deleting policies is the deletion propagation policy, which you can specify to be orphan, meaning that any dependent resource will be left untouched and it's not going to be deleted as well. Background will delete the primary resources first, and then foreground will delete all the dependents, and then the primary resource. So that was it. I hope I've covered deleting policies and mutating policies with enough transparency and knowledge to you guys. And once again, we always love it to see folks come and chat with us in Slack and sharing with us what they're doing with our tools and products. And if you have any question as well, just feel free to come drop it in Slack or open a GitHub issue. And we also love it so much when folks come and contribute to our products and build with us. It's something that we love to see a lot. So yeah, general invitation for anyone to come and interact with us. And with this, I will have ended my demo, and we can take questions if they exist.
Absolutely. These are absolutely fantastic demos. Thank you both. This is a great session. Lots of fantastic questions along the way. We do have, and there's always questions, as I'm sure you both know, being so involved in the Kyverno project, there's always people who are questioning between Kyverno and OPA. I'm sure we just want people to be using policy, whichever one they use. Are we aware of any differences between what's going on between the two projects in terms of moving towards cell policies, or anything that we should highlight for people who are out there considering or working with both projects?
Sorry. Yeah, so the main difference between OPA and Kyverno is that Kyverno policies is written in YAML language, so it's easy to understand and simple to write. So any Kubernetes, anyone that who is familiar to Kubernetes will definitely can write Kyverno policies on the fly, so there's no learning curve. So this is the main difference between these two things. And I would say the other difference is that Kyverno provide more functionalities than OPA. So for example, we have these generating policies if you want to auto-generate resources. We also have the reporting system. As far as I know, there is no feature like reporting in the OPA, so we provide that too. And you can use Kyverno CLI, so you can integrate it, for example, in your CI/CD pipelines. And there's many more.
Fantastic. Thank you for that. I'm not sure. Oh, we have one question that just rolled in. Let's see if I can share it up here on the screen. If we run multiple EKS clusters across regions, how can we ensure Kyverno policies stay in sync without drift? This drift is a problem for everyone. So can we shed a little bit of light for Hermant about this?
Yeah, there are so many ways that you can tackle this problem. one of the ways is to package your policies as an Argo CD application. You can configure your policies to be like a, for example, a Helm chart, and then you can configure Argo to deploy this Helm chart to ensure that it stays in compliance, or like in congruence with what you have in your source control. And then you can have multiple instances of Argo CD in each cluster, looking at this sort of chart and deploying it across your many environments. But that's just one way. There are so many ways and so many products to cover this use case.
For sure. And we're just about on time. We'll finish up with this one last question also from Hermant. He just rolled in. How do you handle Kyverno policies that need to validate runtime states? Also in AWS EBS-backed PVCs for encryption. Is this, I mean, we do see these types of use cases often within our community. Do we have any suggestions for him?
Eventually in the future, we're going to be aiming to cover as many use cases as we can. I'm not sure, for example, that at the moment we can cover use cases for external systems, like ensuring AWS resources are compliant. Well, there is a way, but it's going to be a little bit more convoluted. If you're using one of the projects that generate or like control AWS resources, such as Crossplane, something like this, I'm not sure, but there are projects that sort of link your Kubernetes resources to external entities like AWS resources. And then you can deploy Kyverno on those resources in your cluster, and this way you will have achieved compliance for external systems using Kyverno. But that's just like a bit more bespoke solution, and hopefully we can support this use in the future.
Great. And also for Hermant, or for anybody else who's out there listening, I know that there are a lot of Kyverno users that log issues in the project and contribute as well to finding solutions for them. You can also get support from our team or insights into how to manage a lot of these things in the Slack channels. We've had, just so that Mariam and Amar know, lots of people who are saying that you guys did a great job on your demos. So thanks so much for joining us today. We have people from all over the world who have joined us. So thank you everyone who has joined our live stream. We're just about up on time for the Kyverno team today. We really appreciate you showing up and giving us a demo of everything that's new in the Kyverno 1.15 release. For our CNCF community members that are out there, if you missed part of this live stream, it will be live on the CNCF YouTube channel later today. So that will be uploaded later today. Also, if you signed up for this through the CNCF website, the recording will also be live in your registration link. So thank you so much for joining us. I think we're ready to say goodbye for today, but please keep an eye on other CNCF events for other projects that you're using. And thanks for your questions. We'll see everyone soon.